Mathematicians. Whoa, I get to see Connor today. What's going on, Connor? Did you shower today or something?
I just threw on a hat.
Good. I appreciate seeing a few faces, even though I know it sort of feels like it obligates you to pay more attention, which it actually doesn't. But I feel like I'm teaching some humans. Well, good morning.
Funniest thing happened. This started happening to my house after we started talking about 253 yesterday. I don't know why that's happening, but
Your house started on fire?
I hated 253. It was for some reason like so hard for me to grasp. Like it was fine when you were teaching it, but then when I'd like be off on my own, I would just get lost in the weeds.
Yeah, it's kind of a crazy topic, that concept of infinite series. And I've always said that if you really actually really wanted to learn math, you really do have to take things twice. That doesn't make any sense time and money wise. But if you just kind of erase the whole college and money and all it was I'm just trying to learn something. I mean, I had no other purpose than that. Yeah, I've been really thankful because I really like math, and to have gotten to teach it has been really neat, because I sort of consider that when I took it, even though I got mostly A's, I probably understood 10% of it. I mean,
yeah, I feel like, I try to brush up on stuff and review stuff on breaks, but I do think probably the most knowledge you'd get is like, real world stuff, like kind of like stuff that you have to do with beams and live loads, dead loads, stuff like that. You know what I mean?
Yeah. Well, and you got to connect to it. I mean, even if you're a person that doesn't kind of need the practical stuff like I do, you still have to have some kind of a connection with it, whether that's, time that you spent or whatever, but you got to do something to kind of connect with the material. Let's see, what doeth we today? We are looking at still second order linear differential equations, but this time we're looking at non-homogenous, i.e. not equal to 0 anymore. And your first reaction to that should be, well, that's not going to work, because we had, expressions like r squared plus 3r minus 2 equals, we had junk times kind of our auxiliary equation, stuff like this. And so we said, hey, cool. So this, maybe this was like e to the 3x or something. And we said, hey, look, those two things are multiplied together to be 0. So then we can just look at this one separately and set it equal to 0 and solve it. But if all of a sudden this over here is a 10, you understand you can't do that anymore. And you can't just subtract 10 to the other side and make that a minus 19 because it's being multiplied by something. So, if there's a number on the other side, this is not good. Like, this is really not good. So and in the language of springs, or things that vibrate to a stop like kids on a swing, what was on the other side, you may remember, was other forces. There was friction force that's a part of it, and then there was the force of the spring itself, but then there could also be other forces. And of course that could just be wonky, somebody turning a fan on and blowing the fan on the kid on the swing or something. But one of those forces is just gravity. So, if you're going to put your swing on the earth, like there is going to be there's numbers on the other side. It's not 0 that's over there. They're not homogeneous if we're actually going to model springs. And so that's kind of an interesting part of this. Well, let's just start out with something kind of simple, kind of as teachers call this a warm up. Incidentally, I finished grading everybody's projects, which I graded incredibly generously, because as I said, I really want those to be just kind of playful and fun. I'm not going to nitpick them to death. Generally speaking, as I said, the asymptotic curve, if you will, that we found is found by setting c equal to 0, but a number of you discovered that doesn't always work. And so, there's a bit of a can of worms there we could go into further, but it's like we don't have time. So this is not equal to 0. And so how are we going to solve this? So you may guess, and I'm giving you what I consider to be sort of the easiest example possible. You might guess that if we have to come up with some function for y, picking something like the sine of x would be rather dumb. In other words, we're just trying to guess, because if you stick in sine of x here, and then the derivative of sine of x there, which is cosine, and then the derivative of the derivative, which is negative sine, good luck adding sines and cosines and getting it to turn into e, right? So, I mean, if we're just to guess at this, you probably fairly quickly would say, well, why don't you guess, e to the 2t? Like, isn't that what it's equal to on the other side? Now, again, when it was equal to 0, we did the same thing, except for we said it isn't e to the 2t, it's e to the who knows what it is t, and we found, that might be 5 or something. And so, but here, if you're going to take a derivative of e to the 2t, it's still e to the 2t. And so doesn't it seem like this would be possible to get that to be equal? Like, if we're just to guess, like this would actually be a good guess. Maybe you see some limitations in my good guess, but let's just try it out. So let's see, if that's the function itself, then its derivative would be 2e to the 2t, and its second derivative would be 4e to the 2t, thanks to the chain rule. And so now I just plug all that junk in. I say I have 4e to the 2t's for y double prime minus 2 y primes minus 15 y's. And so the question is, question mark, can I get that to be equal to 4e to the 2t? What's your thoughts on that?
No.
It doesn't quite work. Does it make sense you'd have to get awful lucky? Like the e to the 2t thing, e to the 2t thing was working great. Like we really do have a bunch of e to the 2t's added together. But the problem is, of course, we're trying to land on the coefficient of 4. We say we want 4 of those things. And we sort of, quite not surprisingly, ended up with, well, 4 minus 15. We ended up with negative 15 of them. And so that didn't work very good. Of course, we could actually modify this guess really easy and get this to work. What would it be? What would our modification be?
Never mind.
Okay to be wrong.
You have to go ahead. Oh, no, go ahead.
I was just thinking, make it 4e to the 2t.
Yeah, maybe my guess was 4e to the 2t. Maybe that would be better. What was your thought, David? I don't hear from everybody that has any ideas on this.
I just think you should make the coefficient arbitrary and then solve for the coefficient.
Does it make sense if we pick 4, then we could sort of try this all again and we sort of might get lucky and get it right. But the cool thing is do we actually have to guess at this? I mean, couldn't we just save it for later and say, I don't know what it is, but how about if we make it? How about if we make it equal 4, if you will? Like, let's just not figure out what it is. Let's see what happens here. Of course, if this is the case, then we get y prime is 2a e to the 2t, and y double prime would be 4a e to the 2t. And now if I stick them all in, plug them all into the original equation, I have 4a e to the 2t for y double prime minus 2 y primes and minus 15 y's. And so, is this equal to 4? What it's supposed to be equal to, 4e to the 2t? Well, you might be able to see, well, it could be actually, if you were careful to choose the right value for a. So notice you have a bunch of like terms on this side. So you have 4a's minus 4a's. Well, that's convenient. That just went away. And so you basically have a total of minus 15a e to the 2t's on this side, and you have 4e to the 2t on this side. So I guess if you chose a to be negative 4 over 15, then it would actually work. You agree with that? So this illustrates why it's not a good idea to guess, because you never would have got around to guessing 4 over 15. It's not like these are necessarily going to be whole numbers. But notice there actually is an answer to this. And so we found it. That's the answer.
This particular solution.
Yeah, notice it's a particular solution. There's no constant in it. Well, we started with 1a, but it's like it can't just be anything. The constant that I stuck in there can't just be anything. And so again, this is a little troublesome, and we're going to tackle this in more detail tomorrow, but this might be a little troublesome to you that, didn't these always produce families of solutions, and you have all kinds of answers, and yet, this didn't do that here. And I used the illustration yesterday that says like a kid on a swing, and isn't there initial conditions? Like how far do you want to pull the kid back before you let him go? That's number one. And then number two, you're going to push them with some speed. You're going to let them go, just let them go with no speed. Just release your hands, or you're actually going to push them as you let them go. So it sort of feels like, there should be some initial conditions, but this is actually a particular solution. That's kind of interesting, but it actually does work. Are you bothered by the fact that we just kind of guessed the answer to this? Like we said, well, let's see, what kind of function could I stick in there that I could take a bunch of derivatives of and have it actually work? Probably offends your sensibilities a bit. You're pretty far in math. I mean, the idea of guessing at something sort of feels pretty lame. But for now, I actually have bad news. Like that's the best you can do. You got to get really good at guessing. As I've been alluding to a little bit, there's something coming down the road called the Laplace transform, probably invented. I'm very much dragging this from nowhere. Probably invented because of the idea that guessing just sort of seems kind of foolish as a technique. But it's interesting because it kind of does change things based on what's on the other side. Now, true to our answers before, this still has E as its answer. But just as a side note over here, remember the auxiliary equation for this. If that had been equal to 0, you would have said, hey, that's r squared minus 2r minus 15 equals 0. And I made that up to factor. So it factors to r minus 5r plus 3. And so if this had been equal to 0, you would have said it was y equals e to the 5t, right? Or 5, I guess it is t in this case. You would have said it was e to the 5t, right? Or you would have said, well, there's actually another answer. It could be e to the negative 2t, and you would put constants in front of those. But it's like, notice in this case, well, that's not what's on the other side. It's not e to the negative 2t and e to the 5t. It's e to the 2t over there. So our guess has to be e to the 2t. And so it's, does it bother you at all that we're just kind of ignoring kind of our old technique? Again, we're going to look at that a little bit more tomorrow, but the result is like that doesn't, it's like, can't use those. If this is going to result in e to the 2t, then your guess is going to have to be e to the 2t, or you're never going to get it to work, right? Okay, well, let's open the door a little wider. What about another example where I say that, notice I'm being nice to us by starting with y double prime every time instead of, like 6y double prime or something like that. I'm just making this easy for us. And so again, there's another second order linear differential equation, except for on this time, let's put a different type of function on the other side. We sort of tried an exponential over there, but just think about what kind of functions could be on the other side. There could be e's, there could be polynomials, like we just did, a squared or maybe a cube term, or even a linear term like 3x plus 2 or 3t plus 2. Those are all polynomial terms. Or there could be trig over there. It could be a natural log over there. There's just like, what could be on the other side? Or just a constant. It could be like a 7 over there. And that's interesting. We'll think about that in a minute too. But does it make sense this time? What do you think your guess and again, unfortunately, that's all we can do right now. Let's hear some educated guesses. What might be worth trying? And we might try all of these. We might try a couple of them. I don't know, but like let's you just tell me, what do you think Y might be?
Probably a quadratic equation of some sort.
Maybe a squared. And again, you could just say, well, it's t squared, but maybe from the previous
Probably
from
not.
the previous example, you would say, well, let's put a constant in front of it because probably it's not going to work out right. And so, maybe that would be a good guess. What else? Or maybe I didn't write down what you had in mind, David. I don't know. I mean, it makes sense to pick some kind of polynomial, right? Again, you're not going to pick sine.
You probably want to add a linear term and a constant term to the end.
Yeah, like maybe more stuff to it. Like maybe it just is squared, but maybe it would need other stuff, like that. Maybe it would need the linear term, or maybe even a constant. Maybe it won't need those things. Anybody think like a cube term could be possible here? Why would a cube term be possible?
After you differentiate, you can get the x or the t squared function.
Yeah, right. You're taking derivatives of it, right? So t cubed is going to go down to t squared. So I'd say that's a possibility. And if we're going to go down that road, you might even say, well, I guess we could go clear up to the fourth then, because the second derivative of t to the fourth would be t squared. And so maybe it goes clear up there. And then of course the question is, is the stuff beneath that necessary? It's like, do I add a squared term to this? Or, oh no, I don't need a squared term. I just need a linear term or something. The question is how much other stuff do you need?
So Doug, if you chose a t to the third, you would have different like levels of t essentially throughout your whole left side. Are you able to like combine like terms from left and right side?
Yeah, isn't it interesting? Like if you do have an at cubed, you will take the derivative of it and get at squared, but like there's no derivative here, right? So doesn't that mean you're going to have a cube term? So some of you might be saying, no, that's dumb. Don't do a cube term, because how am I going to get a cube term to add up to, a squared term? But even to Connor's point, you're going to have all of them. Like even if you start with a squared, like I did at the top, at squared, well, when you take the second derivative of it, that's going to take it down to just a constant term. And there isn't any constant terms over here. And this would take it down to a t term, and there's no t terms over here either. So the only one that's like going to help is that one, right? So, you see what I'm just trying to give you time to kind of feel the problem here and how, this isn't super obvious kind of how this might work. Well, let's just try. I don't know, let's try the first one out. So if I did that, its first derivative would be 2at, and its second derivative would be just 2a. So I'm doing what you have to do here. And by the way, this method's title is called undetermined coefficients. Notice I stuck a in there, and now I have to determine what value a is going to take. That's what we just did a minute ago. We stuck a in this problem. We said, there's my guess. I'm going to pick a. And then we had to determine what that coefficient was. We did it. You pick the right coefficient, it actually works. See if we can do the same thing here. So then I plug all this in to my original equation, and I say, okay, the second derivative is 2a minus 5 times the first derivative. Maybe I'll just cut to the chase. 5 times the first derivative. Negative 5 times 2a would be negative 10a times 2t. And then lastly, 6 times no derivative at all. So that'd be 6a t squared. And we need that whole thing to just be equal to 12t squared, right? So if you look just at this, would you agree this will work? Yeah, cool. A is 2. We did it. But what contradiction does that create?
And other stuff is going to have t's in constant terms, and we don't have anything to cancel that out. So
That's exactly right. A has to be 2 in order for this to be t squared, right? But if you pick a as 2, then this is 10 times a times 2 times 2. I mean, that's 40. This is like minus 40t. So that there's no, 40t term over there. And this is a constant, 4. And so there's no 4 over there. And so like this doesn't work. I mean, it's decent, but it doesn't work.
Looks like we're going to need more constants.
Yeah, so the question is, could I, take it down? Could I just add more stuff? In the end, if you will, what I really needed is control over the coefficient in front of the t squared term, in this case to make it 12, but I also needed control over the t term because I needed that to be 0 because there's no t terms on the other side. And I also need control over the constant term. I need that to be 0 too because there happens to be no constants on the other side. Now keep in mind, this problem didn't have to just be equal to 12t squared. It could be, minus 8t. It could have other terms to it as well. But does it make sense? We sort of need control over all 3 terms, all 3 coefficients. And so now I'm thinking this guess, even though there was only a t squared term, maybe I'm going to need all 3 of those coefficients, a, b, and c. Maybe that'll allow me to be a little more diverse in what I actually choose. Let's see if that works. So y prime would be 2at plus b, and y double prime would just be 2a. So now let's plug that back in. So our second derivative, which is 2a again, minus 5 times, and let's just clean this all up at once, minus 5 times this term, so that'd be minus 10at, and minus 5 times b is minus 5 times b, and then plus 6 times just our y guess. We'll notice our y guess had lots of junk to it. So if I say plus 6, there's going to be a lot of stuff going on. So it'll be plus 6at squared plus 6bt plus 6c. And now the question is, question mark, could I get that to be equal to 12t squared? Do I have enough ingredients that I could actually make that happen now? Again, feel free to ask questions, interrupt, stop. This is not hard. I want you to go, this is easy before we're done. But watching me do it once isn't going to make that happen. Well, notice we only have one t squared term. That's it. And we need 12t squared. So does it make sense right now? You can say for certain, you can box it. We're done. A has to be 2 or this will not work. Do you agree with that? The question is, does that create any contradictions? Well, notice our equation has t terms as well. So I have minus 10at plus 6bt. And what do I need that to be equal to?
0.
No t's. Like, isn't there no t's on the other side? So in other words, I need negative 10a plus 6b to be 0. Can I still make that happen? Now that a is stuck to be 2?
It's going to be 20 over 6, right? B will be 20 over 6.
Yeah, you can. In other words, if a is stuck at 2, then doesn't that, and if you add it to the other side, don't you get 6b equals 20? So now b is 20 over 6 or 10 over 3. So it's like you can still make that happen. The extra terms we added gave us a little bit more freedom. So we're still okay. Like this actually might work. Finally, look at the constants that you have. It's time for pink. Pink never gets any play. Look at all the constants. 2a minus 5b plus 6c. 2a minus 5b plus 6c. That all needs to be, well, again, what do we have on the other side? We don't have any constants. If it had been 12t squared plus 7, we would have said this equals 7. but there isn't any constants in this problem. And so it's equal to 0. Can we make that happen? Being stuck with A being 2 and B being 10/3. Well, yeah, we can, because there's still a C value there. So we can make that happen. So let's see, mood to suffer. So I'm gonna add 50/3 to the other side, 50 divided by 3. I'm gonna subtract 4 to the other side. I get a number. I'm gonna divide by 6. I get a decimal that I don't immediately recognize. I convert that to a fraction of my calculator and I get -7/18. C is -7/18. So this actually seems to have worked. So I don't feel very confident, you should say, but we're basically saying it was AT², so 2t², and then plus BT. But we just figured out B was 10/3, and now we just found out plus C, but C was -7/18. So we're saying that's an answer. Like, does that actually work? Well, it should. Like, didn't we didn't screw anything up, did we? Notice I apparently just made this up from scratch because that didn't come out very nice, right? Our A, B, and C didn't come out nice, clean, whole numbers. That would have been nice that I made this up. But I, just to give you time to soak on it, I find myself wanting to check because I just can't believe this is really working. So I get 4t plus 10/3 for my first derivative, which means my second derivative is just 4. And so now I'm going to basically put those back in. I'm going to plug that back in. And we said y double prime, forgot the equation, minus 5y prime. We'll go ahead and write this out. Plus 6y and that was a complicated business. I didn't plan ahead, so I'm having to write really tiny now. We said that whole thing was actually supposed to equal 12t². And, don't you find yourself going, that's awful messy. It's hard to believe that with all those fractions and everything, that's actually going to happen. So, let's progress. 4 minus 20t minus 5 times 10 is -50/3. 6 times 2t² is 12t². 6 times 10/3 t is 60/3, which happens to be 20t. And then 6 times 7/18 is 42/18. That doesn't go in evenly, does it? 42/18. Certainly reduces. 21/9, 7/3. Again, I'm saying, does that really equal 12t²? Well, notice there's only one squared term. So that appears to have worked. What about our t terms? Okay, look at that. -20t, +20t. That's good because there's no t terms over there. Now look at my numbers. 4 minus 50/3 minus 7/3. Minus 50/3 minus 7/3 is minus 57/3, which is -19. -19 and 4 does not equal 12t². So it either didn't work or I blew it somewhere because I did not get 0.
Yeah, actually for my C value, I got 19/9. So
yeah, who can tell me where I screwed up?
I think it was probably that last step, finding out the constants, the constant values.
So 47 times 6 is 42. 42 over.
It might have been when you're actually like figuring out what C is, like before that.
Our C value might be wrong.
Yeah, maybe that C isn't -7/18. Maybe I got too much of a hurry there. And again, I frankly hope I got that wrong because, this is the kind of thing you should do. You should check your work. You should know. So that But I will say, like, the process actually worked. Like, this is working, but I just made some kind of a dumb math mistake. And notice, because I went too fast, now I'm condemned to go look at every single thing I did. If I'm by myself, I'm condemned to check every single thing, and until I finally figure out what I did wrong. I'm not going to spend too much time at this, but I certainly want to spend a little. Let's see, A was 2, B was 10 thirds. That would be 50 thirds. Oh, I see my calculator. I said 50 thirds minus 4, but I look at my calculator and the 0 didn't show up. I ended up with 5 thirds minus 4. So 50 thirds minus 4 divided by 6. Convert that to a fraction. It was supposed to be 19 ninths, as one of you said. So, in my case, I don't want to say it wasn't my fault, because it was my fault. But I tried, the 0 just didn't show up when I hit it on my calculator. I totally remember typing it. So C is actually 19 ninths. Notice then that that's going to change just a few things, but that's just kind of good to check. And if you will, I got really lucky in the sense that I didn't have to go very far. Everything else stays the same. This is now plus 19 ninths. So not very much actually changed here, fortunately. 6 times 19 ninths, 6 times 19 divided by 9 is some decimal. That's actually 12 and 2/3. But as a fraction, it's 38 thirds. So this right here was not supposed to be, it's supposed to be negative 38 thirds. Again, I'm going too fast. I could be making another mistake. I took 6 times 19 divided by 9.
Oh, but now it's positive 19 over 9, right?
Is it positive? Is it positive? Yeah, it's positive. So that makes this a positive. So I did make a second mistake. Again, I'm glad to do that in front of you, because notice there's no guarantee you're just going to make one. So what about now? Did that fix it? Well, let's see. Negative 50 thirds and 38 thirds would be negative 12 thirds. Hey, that's negative 4. 4 and negative 4 is 0. And so there we go. I caught my mistake. And so it actually did work. Eventually. Check. So this is all my check. And again, notice this is interesting. This is a particular solution. There's no constants left. Like, we can't just leave those as A, B, and C. They had to be very particular numbers. We had to, well, in the language of this section, determine those coefficients. So this will not work unless those are the coefficients.
Hey Doug, what was our initial Y again that we chose?
We chose, for a second trial, we chose this. We said maybe
Okay.
it needs the t squared term, but maybe it needs the other terms too. And notice it turned out it did. Like, you'd sort of think, well, it doesn't need those, but it actually did need those.
Yeah, I didn't notice that C at first. It really came in handy. So for polynomials, would you always kind of recommend doing one more variable than the maximum polynomial? Like, so for if it was AT to the 5th, we should do 6 constants.
Well, in this case, it was, I see what you're saying. In other words, this expression right here was squared. And so we ended up with 3 terms here.
yeah,
I think that's true. What it appears to me, another way to look at it is this was a squared term. And then that means your answer needs to also be a squared term, but it needs everything below it.
Right, you go down to the 0th term. So you have a t squared, a t to the 1, and a t to the 0. So
Exactly.
you just
That C is a t to the 0. That's exactly right. And so doesn't that seem like the case? Now, I'm not going to take the time to do this because we have other things to cover, but I will ask you this question. Do you think this would work then?
It depends on what you're, I mean, if A is equal to 0, then yeah.
Yeah, it actually does work. And in the process of determining the coefficients, you will say, okay, I have an AT cubed You know, what does that need to be equal to? Well, there's no cubes. There's no cubes. And so A is 0. Like that actually will work. Now it's just going to make your life harder, right? It's going to take more time because now you got 4 coefficients, A, B, C, D, to figure out. And so it's going to take more time, but you're going to get the same answer, except for, you know, you'd end up with A is 0. You'd get B is, what we said was 2, and C was 50/3. And D was 19/9. Like you'd still get the same answer. So that's just kind of cool. So you can, if you like pain, you can go higher than the degree of the function that's on the other side, but you don't need to. But you actually do need every single term along the way. It's kind of interesting.
Well, does that mean there's no family of solutions, just explicit solutions?
Yeah, isn't that weird? So there's not a family of solutions. Now I'm going to come back to that tomorrow. That's part of the discussion tomorrow. There's no family of solutions. There's one answer to this for now. Yeah, you have no choice. You're stuck with these coefficients.
I like
This
how
is
you flip in the for now at the very end.
Say that again, Connor.
You're like, you're stuck with particular solution
Yeah.
for now.
Yeah, that's exactly right.
Yeah, so tomorrow we're gonna get the family again.
Yeah, tomorrow your family gets to come home.
This is like
That's
the easiest and the
bothering you.
hardest one so far.
What do you know? My house is still on fire. So we're getting the family solutions back.
Let's see. So what we got to do is, if you will, kind of just write down kind of how you approach your guesses. And let me show you my cheat sheet on this, because it does collect together what we just said. And I want you to stare at this for a second. Try to ignore part of this. I'm gonna circle just parts of this for you to think about. If your equation is this, notice I'm ignoring that for a second. I'm just going to cross a couple of things out here and I'll, put them back later and we'll talk about them. But if that's your equation, notice what you see on this side. It's some constant. Doesn't have to be just t to the 4th. It could be 4t to the 4th. What do you see sitting down here as your guess? What's your guess? Isn't that exactly what we just said? Is that speaking to you? If you started out with 9t to the 7th, m is 7. Then you come down here and you better also start at t to the 7th. And then what does this say? It says take 1 away from that. Now it's to the 6th. If m is 7, 7 minus 1 is 6. And then notice it's like dot, 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 all the way down to, well, what do you have right there?
T to the 0.
Yeah, t to the
question,
0, it's constant.
Does this only work with t to the m, or could you have like additional terms? Like, could you have like 9t to the 7th plus t to the 4th?
Good question. In other words, what if that was 9t to the 7th plus, 8t to the 5th plus 9 or something like that? The answer is yeah, that'll take care of it.
Oh, so we can just do the same thing?
Yeah, just do the same thing. Because remember a second ago, we were always setting our work equal to 0 all the time. Where did that happen? We set this equal to 0. We set this equal to 0. Well, would it have changed if this had just been an 8?
Right.
No,
Gotcha.
doesn't change at all. So yeah, you don't care if there's other terms beyond that. Fine, I don't care. Doesn't change a thing.
Does it only work with integer powers? Or probably.
Yeah, that's a wonderful question. What if it's like t to the 2/3 or something like that?
I guess you can't have 2/3 terms, so probably not.
Yeah, but I want to compliment you, because that's what mathematics is trying to solve something and looking for a pattern and then asking other questions, like, what will this work for? I mean, that's what you should do. Notice though, this contains everything we just said for both of the example problems I just gave you. Do you see that? In other words, look at the second part of this. What if there's an E over there? E to the 9t. Well, then, duh, your answer better have an E to the 9t in it. Does that make sense? And so, you know, if this doesn't have this term, then it doesn't have this term. It's like, that's not there either. Isn't that the first thing we did? Now, you may notice there's a couple of weird things here. Do you notice that there's a whole bunch of other junk here? Like, there's kind of like, you know, it's sort of like I before E. When you spell words, it's always I before E, right? Except after C. Well, this is the exception. And notice there's also something out here that I was ignoring. So like, what's all that? There's kind of like an exception to the rule. Well, let's play with that. So I'm going to make up a problem here. And this is going to go in the ditch. This isn't going to work. Let's make it easy. No, let's make it this. What's your guess? What's your guess for Y? Can you make the right, at this point, you should be able to make a genuinely educated guess, like the correct guess. Like you shouldn't be wrong now.
Is it going to be AT squared plus BT plus C, and then all of it multiplied by E to the 5T?
Notice what's your exponent right here? That's 4T
Oh wait,
to
I'm
the
sorry.
what?
I meant just AT plus B.
Yeah. So notice that's only T to the 1, which means our polynomial just needs to have that many terms, right? So in other words, if the E to the 5T wasn't there, wouldn't that be our guess? And we know it's going to work. We're just going to go get it. We're going to have to determine A and B, and there'll be very particular numbers, and we'll have to figure out what they are, but we'll be able to make that work. But if this also has an E to the 5T, then this answer is also going to have an E to the 5T, because we're not going to be able to, you know, take a bunch of derivatives and so forth. We're not going to be able to produce the E to the 5T unless there's an E to the 5T. Now, the note sheet said those need to be multiplied. I don't know about you, but my first instinct is to think they should be added, like not multiplied. But then I think, well, I guess they're multiplied up there. Does that make sense? Maybe if these were added up here, then they would be added down here. So maybe they do need to be multiplied. Again, I obviously already know the answer to that, but I'm just thinking out loud to kind of give you time to process.
Adding is tomorrow.
Yeah, we're going to look at addition tomorrow.
With the family reunion.
Exactly. We're having a family reunion tomorrow. It's going to be awesome. Well, as long as that weird uncle doesn't show up.
I think you might be the table, Doug.
The other question is, do you think I need like a third coefficient in front of this, like a C? I wouldn't say that's obvious. What's your thoughts on that?
I was thinking that at first, but then I thought maybe since the B's already been multiplied by it, it's already a constant, so maybe it'll take care of it.
Yeah, that's a wonderful thought. Notice he didn't necessarily answer the question, but he's just thinking, well, maybe I don't need it, because if you distributed the E to the 5T in, wouldn't it be multiplied by B? And so then it does kind of have a coefficient in front of it. Again, we don't have a ton of time in this class, but it turns out that's actually true. Again, is it wrong though if you threw a C in front of it? No, It isn't. You'll still get the same answer everybody else gets. But you don't need it. The other question is, before I start taking derivatives and stuff, should I multiply this out? Should I distribute the e to the 5t into it or not? It ultimately mathematically doesn't matter. And I actually don't know what's easier. I'm just going to leave it alone. So of course, to sort of force this thing, because that's what we're trying to do. We're not trying to guess and hope it's equal to 4t e to the 5t. We're going to force it to be the case. So we're going to, right now we don't know what a and b are, but we're going to make them produce the answer that we want. So you should see product rule. So the derivative of at plus b is a times e to the 5t left alone plus the at plus b left alone times the derivative of e to the 5t. The derivative of e to the 5t, of course, is e to the 5t, but chain rule times the derivative of 5. 5t is derivative of 5t, which is 5. So there's the first derivative. And notice this feels like, whoo, it's going to be complicated. When I plug this back in and try to get this to be 4t e to the 5t, it says feels like, this is going to be fun. It's going to be painful. But now I'm thinking for a second, maybe I should clean this up a little bit. In other words, a e to the 5t plus 5a t e to the 5t. I'm just distributing plus 5b e to the 5t. Do you think I should be doing that, or is that just making it worse because now I have more terms?
Wait, didn't we miss doing the other part of the product rule when we taking the first derivative?
I don't think so. I took the derivative of this, which is a.
Oh yeah,
e to the 5t left alone. Okay. Thank you for asking.
Yeah.
I don't think I did. I think this could save some time because notice I can't add these two terms together. Do you understand that? Because those are not like terms. But I can add these two together because they both have an e to the 5t. So I have a plus 5b e to the 5t, and then I have a 5 a t e to the 5t. Again, I don't know. I'm not sure. I think it's going to be easier to take the derivative of that. I don't know. Algebraically, you should feel solid enough. It's like, I don't know, who cares? I'm going to get it right either way. Maybe it's a little harder the way I did it. Maybe not. Who cares? I can do it. This isn't hard. So I feel myself getting lost. So I'm going to say this is the one I'm going to work with because remember, I'm going to need this later on. So I'm going to kind of highlight the two that I have. And now I got to get the second derivative, which feels really terrible. And I find myself thinking, I hope nobody ever gives me a third order equation like this where I have to take a third derivative, although I could see that it could be done. That sure doesn't sound like a lot of fun. So now I've got, is this a product rule question?
No.
It isn't, because a plus 5b is just a constant. Now, it isn't like you can't treat it like a product rule problem. What's the derivative of a plus 5b? Nothing, because it's a constant. But the derivative of that would just be 5 times a plus 5b e to the 5t. So that's done. And then this plus sign comes down. And now I do have to do the product rule because I have a t e to the 5t. So I'm thinking of the multiplication as being there. So the derivative of 5at, of course, is 5a times the e to the 5t left alone. And then plus the 5at left alone times the derivative of e to the 5t, which is e to the 5t, times the derivative of 5t, which is 5. So 5 times 5 is 25. So I think I've got the second derivative. Now, again, I got to do stuff with this. So I find myself thinking about, could I clean that mess up a little bit? Do you see that you can? Like this is a constant term, e to the 5t. This is a constant term, e to the 5t. It feels like I could add all that together. So don't I have 5 a's plus another 5 a's for a total of 10 a's? And then I have 5 times 5b is 25b, and then there's none of those over here, so that's 25b. And then there's nothing I can do with that because it's got a t term in it. So, it feels to me like if I have to do something with it, that might be a little easier to work with. I don't know. I don't really care. I'm gonna get it right anyway. So now I'm just going to plug it back into that mess and I'm going to force it to be equal to 4t e to the 5t. I only have two unknowns, A and B. So the question is, will I be able to force that to be equal to 4t e to the 5t with some particular choices for A and B? So second derivative. Rewrite it so I can make it nice and small. 10a plus 25b multiplied by e to the 5t plus 25at e to the 5t. On a test, is your work going to be clear enough for me? Some of your work is really good. It's so easy for me to follow, and I can find your, accidents. You're going to make accidents with this stuff for sure. Am I going to be able to follow it? Some of your work's a mess, and I might not find it, or I might just get tired. Like, I just can't look anymore. It's too hard to work. I can't do it. Minus 3y primes. Minus 3y primes. That'd be 3 of these. And 3 of these. That'd be minus 15 of them. I wrote really small, but it didn't help because I couldn't fit it on there anyway. And then finally, I have minus 10 of the y's, minus 10 of the y's. So minus 10 of the y's, which was at plus b e to the 5t. And of course, what I'm trying to do is force that all to be equal to 4t e to the 5t. And of course, if I'm new at this, I'm wondering, did I even make the right guess in the first place, right? In other words, is this even, was that even the correct guess? Because if I'm new at this, there's no guarantee I got that right. But we learned a couple of things. We're on the right track here for sure. This is going to work. But of course, the algebra is really messy here, right? So do you notice you have t e to the 5t terms? I'll circle that. And again, that's a description. So, we use the word coefficient and variable, and we say 5x, and students get really confused when they're first learning algebra. It's like 5x, and we have all these terms, like 5 is the coefficient and x is the variable, and you can see why people get really confused by that. But we do this all the time, every day. We say, I have 6 dogs. 6 is how many you got. Dogs is what you got. So, t e to the 5t, that's dog. But then you also have e to the 5t's. That's cat. I mean, it's close, still an animal, still a pet, but it's not the same. I mean, like, this is not hard. When we give it names and so forth, yeah, it gets complicated. So I'm very concerned I'm going to screw this up. So I'm going in here right now and kind of circling all the t's. I guess I don't really need the one on that side. And then I guess this is a little messy because there's a t right there. But so I'm staring at that and I'm thinking, okay, what do we have? Okay, well, let's see if we can write this whole thing out. So I've got e to the 5t terms. And let's just think about what we have. Well, we have 10a of them. And we have 25b of them. But what else do we have? Don't we also have minus 3a of them? You can see that isn't going to work too good. Notice I also have minus 3a of them from this, and then I have minus 15b of them from that. And then I have minus 10b of them from that. There we go. So all together, that's my e to the 5t terms. But then I also have t e to the 5t terms. And so what is all of that? Switch colors. Let's see, I've got 25a of them right there. And then I've got minus 15a of them right there. And then I've got minus 10a of them right there. And that's it. And I'm going to add those. And I need it to be equal to 4t e to the 5t. Can you see where we're going with this? Well, hey, this is a t e to the 5t term, so is that. I need that to be a 4. I need this to be a 4. There's no choice. That has to be 4. Notice I'm really happy up there to see that there's no b's in that. That almost feels like I made a mistake. And again, for me personally, there's almost no way I'm not screwing this up. Just out of stupidity. It's not like I don't know what I'm doing. But man, there's just a lot of stuff you could do wrong here. Well, let's see, what is that? 25 minus 15 is 10. 10 minus 10 is 0. Ooh, that's not good. Whoa. You with me there? Uh-oh. Uh-oh. Doesn't that seem unlikely that that just happened? The coefficient is 0? Oh, no. I mean, it could have been 5a, 12a, 16a, anything, and I could have made it equal 4. But you're not going to get 0a to equal 4. Did I make a mistake? The answer is no. Like, I'm okay here. Remember what I said before?
That it would be wrong.
That guess won't work. Now, it's a tremendously unlikely exception to the rule. I before E, except after C. It's always I before E. Well, except after C. This is your guess. Except, and I want you to stare at this exception now. See if you can figure that exception out. All I want you to do is stare at what's in the circle. It says S equals 0. Notice where S is. This is where S is right there. Whoa, that's not what I meant to do. There's the S. That's the only place S is. S is 0. Notice it says, well, t to 0. That's 1. In other words, if R is not a root of the auxiliary equation, don't you find yourself reading that going, I don't even know what that says. I don't understand. I gotta read that twice, 3 times. It's like, I don't get that. In other words, don't add this term. Don't do that. Don't add it. It's not there if R is not a root of the auxiliary equation. Well, isn't that what we did? We didn't do that. We didn't add that. However, it's saying do add it. In other words, there's an extra t sitting out in front of this thing. That's t to be multiplied inside. So a second ago when we said, hey, we have a times t plus b, that was our guess. That was this condition. Non-exception to the rule. That's the typical guess. However, this thing actually has to get multiplied by a t to the first power, if R is a root of the auxiliary equation. Again, I bet you find yourselves thinking, I still can't really, R is a root of the auxiliary equation? What? In other words, this is saying your guess should not have been AT plus B, it should have been AT squared plus BT. You needed an extra T for that to work. That's what just happened to us. That would have worked great, except for this weird exception to the rule.
Why is that the case?
Yeah, so our guess should have been AT squared plus BT multiplied by E to the junk.
Yeah, everything else was fine.
And that's the case because 5 was the root to the equation.
If
But why would
R is a root. Yeah, and let's look at R. What's R? There's R right there. R. What was that for us? 5, right? But then they talk about the auxiliary equation. Like we never even used the auxiliary equation, right? Because that was when it was all equal to 0. We didn't even need that. Let's go back and look at this question. So, stuff's so easy. You gotta take your time. You gotta play around with it. You gotta mess around a little bit. Let's consider what the auxiliary equation for this is. Auxiliary equation is r squared, thanks to that, minus 3r, thanks to that, minus 10, thanks to that, equals 0. And if we were to solve this, again, I made this up to be really nice, you end up with r minus 5, r plus 2. And so you get r is 5 and r is negative 2. Uh-oh. Uh-oh. That's 5 and that's 5. If that's the case, you got to add another t or it won't work. So I didn't do anything wrong, just my guess didn't work. Usually it will. I probably will not put a question like this on the test. I say probably, I'm not sure.
So why does multiplying the t in there fix it? I mean, is it just something else to try, or?
Yeah, well, no, it's not necessarily that, but think about this. Think about what happened back here. Weren't you surprised like me that this only had a's in it?
Yes.
And that would have been okay though, you know, as long as it wasn't 0a. If it had been 10a equals 4, then we could have found an answer for a. And then notice up here, this answer, we needed none of those. And so this would have had to have been equal to 0. Well, we could have made that equal to 0, couldn't we? No matter what a is, because it has some b's up there. That's the idea. So in a sense, what we might say is it would have been nice if there were kind of A's and B's in both camps, and you know, then I would have had more options. But basically what I needed is I needed A not to cancel out. And so it's like, why did it cancel out? Well, it canceled out because there just happened to be a match between these two. Can you agree that it took somebody a long time to even run across this exception to the rule, let alone try to figure out how to get out of it?
Oh, I see. If you have like a t multiplied by the b term, then as you take the derivative, it'll kind of stick around longer and probably end up in our expression.
Yeah, that's kind of the idea. It's basically going to cause things to stick around longer. And notice, while we're staring at it, since we will run out of time at some point, notice there's even a worse case. What is this one saying? Now you need to multiply by t squared, which means it'd be at cubed plus bt squared if r is a double root. Let's see, can I make up a problem where that would happen? Y double prime minus 2y prime plus 1y. That's the auxiliary equation. Would you agree that factors, or that auxiliary equation is r squared minus 2r plus 1? Why is that an unusual one?
It's a perfect square.
Because it factors to r minus 1, which means r equals 1 is a double root. Remember that was a pain before too? Remember that was a pain even when it was equal to 0? That was like a special case that you better be aware of. It's a good thing, you know, this is an open note test. Remember we had a way of dealing with that before? We said if it happens to be repeated, then you've got to kind of add this little t term in there. Remember how we added a t term? And I gave you kind of an extra credit to do it. Well, that's what we're doing here too. We're adding a t term. That's what gets you out of this mess. So far as a double root, now, does that mean we automatically have to change our guess? Well, notice r is 1. The only way this would be the case then is if on this side we had an e to the 1 t. Does that make sense? It's got to match. If there was an e to the 2t over there, no problem. So somebody's got to try to make this happen, right? Like this isn't going to happen on its own, on accident. It's going to happen because someone's trying. And I have a pet peeve that mathematicians spend a little too much time on all these weird exceptions to the rule.
So anytime there's an e on the right-hand side, it'd be a good idea to do an auxiliary equation.
Yeah, and as it turns out, tomorrow we're going to see that there's a reason to do the auxiliary equation anyway. So in a sense, tomorrow we'll kind of pull all this together. So we'll get a chance to kind of practice this a little bit. So let's go back and kind of redo this. And so since that's a match, we're saying the right guess. And does it make sense if we had either had this memorized or we're staring at the note sheet, we never would have guessed the wrong guess in the first place? Because that turned out to be a giant waste of time. We would have checked and said, hey, look at that, it's a match. one of the roots of the auxiliary equation, r is 5, happens to match the e that's on the other side. And so don't guess that guess. You got to multiply by t to the first. So that means the right guess should be at squared plus bt.
Should we check the auxiliary equation even when there's no e term? Because wouldn't that mean that the root is 0?
Yeah, and the answer is no. Like if there's no e term, that was the only case because the r in that formula was up there in the e. So if there's no e in it, you don't have to check that.
Oh, okay. But so wouldn't it say that the root is 0 though, since the e's gone?
Let's see. That's a good question. You agree David's point is kind of well taken? Like if it's, well, that's, yeah, because if it's
Like,
e
so
to the
if r
0t,
isn't-
that's actually 1. And so there being no term means r is 0. And so maybe,
So wouldn't you have to check the auxiliary equation and then maybe multiply a t in there?
yeah, and my gut reaction is, I haven't thought this through because I think your question's a really good one. My gut reaction is that's exactly what this is saying to do.
Okay.
Yeah, I guess I don't think it is. That's repeated roots.
Right. And
So
that's
yeah,
not-
actually, if there's no, I think you're right. I'm going to let that hang. I'm not going to completely answer that. But if this was e to the 0t, then you're not going to see it, right? Because that's 1.
if I'll be careful when I come across something like that, and I'll just
Yeah,
around.
we got to think about that. That's a great question. I'm really
That's
glad.
a pretty twisted thought. My goodness.
I know it is.
Yeah, that is a weird one.
I know I got a little scared.
Yeah, like if you ever become a math teacher, I'm just terrified for your class.
This is what mathematicians do. They ask questions and they look for exceptions and so forth. And you can see that I could make this test so that every problem I gave you was an exception and you'd like burn all the time in your test trying the wrong. Because if I give a test question like this, not everybody's going to notice that this was one of the exceptions. And then they're going to do everything I just did. And then they're going to get down here and see that 0a has got to be 4. And of course, your conclusion is not going to be, oh, I made the wrong guess. Your conclusion is going to be, I screwed up someplace, and you're going to spend another half an hour staring at all of your work trying to figure out what you did wrong when you didn't do anything wrong. And so I could make everybody fail this test really easy by just giving trick questions for every one of them, right?
And I fall for everyone, Doug. I promise.
Yeah.
So let's redo this just as fast as we can. And I'm probably going to make a mistake, so please interrupt. Watch me do this and help me not screw this up. So the derivative of at squared plus bt is 2at plus b times e to the 5t left alone. Product rule. Leave the at squared plus bt left alone. The derivative of e to the 5t is e to the 5t times 5. And so there's the first derivative. I'm going to not simplify this time and speed on. The derivative of junk e to the 5t, this first one is just 5 times 2at plus b e to the 5t. There's that derivative done. It's not product rule. The second one is product rule. So the derivative of the first expression
Isn't that
is,
first one product rule.
this is product rule.
That first one should be too. It's got a t in there.
It does have a t. It's screwed up. Let's start over. It's got a t, and that's because I did not simplify it last time I did. Thank you. So the derivative of 2at plus b is just 2a times e to the 5t left alone plus the 2at plus b left alone times the derivative of e to the 5t, which is e to the 5t times 5. Thank you for rescuing me. And then the second one is also a product rule. The derivative of 5at squared plus 5bt is 10at plus 5b times e to the 5t left alone, plus the 5at squared plus bt left alone times the derivative of e to the 5t, which is e to the 5t times 5.
Looking good.
Anything wrong with that? Again, my temperament, I make a lot of dumb mistakes because I go way too fast.
I think you're okay. But I go fast too. So
So Now I'm going to add this. I'm even going to get in more of a hurry here. I'm going to add this minus 3 of these minus 10 of these together. I'm going to try to do that without rewriting the whole thing. That seems like a bad idea. But again, what I'm looking for is the two types of terms I have. I have e to the 5t terms, and I have t e to the 5t terms. So what I'm going to do is farm through all of that and try to gather them together right now. So right here, I have minus, let's see. Oh, that isn't true, is it? Don't I have a t squared term too? There's even more. I also have t squared e to the 5t terms now, don't I? So let's go in order and just put them all in there one at a time. I'm going to rewrite this in red and just kind of cross them out as I go. So there's a minus 10 at squared. So there's a minus 10 a right there. T squared e to the 5t. Agree with that? And then here's a minus 10 bt. So there's a minus 10b because there's the t. You okay with this? And then here, there's a minus 6at. So that'd be right here, minus 6a. And then there's a minus 3b, but that's actually up here because that didn't have a t term in it. And then it's also minus 3 times this. I'm afraid I'm going to forget that. So that's minus 15at squared. So that's minus 15a. And then minus 15bt. It's so dangerous. Like the chances of me not making a dumb mistake here are so slim. Fortunately, the y double prime had nothing multiplied by it. So let's see, what do I have? I have a 2a. I have a 10at. And I have a 5b. And I have a 10at. And I have a 5b. And I have a 25at squared. And I have a 25bt. Anybody see any mistakes in that?
No, but
No, but there probably is one. That's kind of my thought too.
no. Well, there's only a's in front of the t squared e to the 5t, so it's going to become 0. And would that mean that, like, we want that to be 0? I'm pretty sure. But
isn't that kind of cool? Take a look at what happens as a result of this. Like, and you can see why this multiplying by t actually fixed the problem. Notice, because of the match between the root and the e to the 5t, notice this, the same thing happened here. You have 0a equals t squared.
does that mean a can be anything?
So that means a can still be anything. You see how cool that is? Like, it's 0a. So that means a could still be 5 or 7 or 9 or 18, and this is going to be gone. And so a can still be anything. Isn't that kind of cool?
That is handy.
That's why it fixed it. Isn't that neat? Now, don't we need all of this? What do we need all of this to be equal to?
I forgot.
4t e to the 5t, right? We need all of that to be 4, don't we? So that it's 4t e to the 5t. What do we need all this to be equal to?
0.
0, because there is no just constant e to the 5t's over there. In other words, this problem did not say plus 9 e to the 5t. Does that make sense? Could it have said that? Yep. And then we would have said it equals 9 instead of 0. It's not hard. It's just kind of mind-boggling, isn't it? Now, what's really good news about what I'm staring at here? Why do I know this is now going to work?
None of it goes to 0.
You have 2 equations, 2 unknowns. I have A's and B's up top, and that needs to equal 0. And then I have A's and B's here, and that needs to equal 4. I have 2 equations, 2 unknowns. This is going to work. You see what I'm saying?
So Doug, I think my algebra might be a little shaky. Why does 0a to the t squared make a anything?
No matter
gotta-
what, it'll add up to 0. So if you made a like 1, or if you made a 2, all of them are multiplied by the same thing. So -10 minus 15 plus 25 is just 0. And so you would,
Yeah, because there's none of these on the other side. There's no t squared
Oh.
e to the 5t's on the other side. Therefore, we need this side to be 0. Fortunately, because it came out 0a, a doesn't have to be 0. Isn't that cool?
Okay. Yeah, I'm with you. now.
Otherwise, a would have had to be 0. If this was 8a, we would have said, okay, 8a has to be 0. Now a has got to be 0. That's why adding the extra t term turned out to be a brilliant idea by somebody that we just stole. We didn't make for ourselves. So
Okay.
now I'm going back to these 2 equations up here, and I'm just collecting junk together. So I'm looking back up. It's purple time. -3b and 5b and 5b. That's 10, and -3 is 7. So I have 7b of 2a plus 7b, and that has to be 0 so that I have 0 e to the 5t's. And then let's look down here. -6a and 10a is 4a plus 10 more a is 14a. Again, tell me if I do something dumb. -10, -15 is -25. Ooh, that's interesting. Plus 25. That's actually no b's at all. Isn't that interesting? There were no b's. I have a feeling that's not a coincidence, by the way. We wouldn't have cared if there was a b term because we have 2 equations, 2 unknowns. It just makes it easier to solve for us because now we can say, oh, look, a is 4/14 or a is 2/7. So it's easier. And now that I know a is 2/7, of course, I got to put 2/7 in here. Solve for b. So I get 4/7. Subtract it to the other side. Divide by 7. So b apparently is -4/49.
oh, those answers just aren't very encouraging.
No, doesn't that feel like, man,
No, there's no
wrong?
aha moment.
And of course, this is so painful that I find myself not wanting to check it this time out of laziness. But, you know, I should be, right? Like, what's the chances I, got this right if I'm you and I'm taking my test and I'm all by myself? I'm definitely checking this if I have time. But again, I want you to separate it out. If I got this wrong, did I get it wrong because I don't know what I'm doing? No, I know what I'm doing. Just did something stupid, right? Incidentally, these problems are pretty hard to make up to come out with nice whole numbers. I would love it if A came out 5 and B was -3 or something like that. I would have felt a lot better, wouldn't it? So I'll think about that when I make the test. I can't remember off the top of my head. It's one of the things I always do when I make tests is try to, keep the focus on you just showing that you understand the concept.
Straightforward answers.
So then we are saying that AT squared, 2/7 t squared plus BT times e to the 5t. That's our answer. It's a particular solution. We're going to write a little p there. We're saying that's it. So if we did go back, take the first and second derivative, plug it all back in, we actually should get 4t e to the 5t. And no t squared e to the 5t's, and no e to the 5t's, just 4t e to the 5t's. Woo! Man. That's intense. We have time for one more important example. So there's sort of, we've put polynomials on the other side. We've put e on the other side. The only thing we haven't put on the other side now is trig. And I guess we could put logarithms. I mean, there's a lot of things, but let's put trig on the other side now. Except for this time, let's just go straight to the note sheet because we're going to run out of time, and just kind of cheat to get the correct guess from the start. Okay. So here it is. This is your last example with some trig on the other side. Dude, that's not cool. Y double prime minus 5y prime plus 6y. Let's have that be equal to t squared cosine of 2t. So there's a polynomial over there, and there's trig over there.
What? No E term?
Yeah, there can be an E term too, but you know.
For what you say, David.
Anybody like pain? Cosine of the natural log of t.
Make it
Throw that
full.
in there. But again, I do want you to understand, like, this is what mathematicians would do, is say, you know, like, what can you actually solve it no matter what's on the other side, or is there like some you can't solve? I did notice, by the way, in this section, there's no logarithms on the other side. They never do that. I wonder why. Is like, so is that terrible? Is it impossible? And that's why it's impossible, it turns out. I bet you the person that wrote the book, I bet you, by the way, this is the, ordinary differential equations class. There are other differential equations classes after that. Perhaps that's something you would address. And I find myself thinking, I don't want to address that unless there's a practical problem in the real world where you would need to know it. And then I'm totally excited to address it. That's my temperament. If you're a true mathematician, you would say, I now have, hours and hours and hours of investigation here to see just what kind of functions are on the other side. And of course, do they have any weird exceptions? And I'm going to create this rule. So notice what's on the other side, t squared cosine of 2t. What does our note sheet say for trig? Let me get rid of all this other nonsense.
Probably want to figure out what our roots are.
Yeah, so are there any exceptions here? Notice there is some exceptions down here. Notice the guess actually does include, what if there's even an e to the t over there? What if there's not only polynomial, what if there's not only e, but also trig on the other? So it could be all those things. Notice these two cases right here are like almost identical. Like one just has sine and one has cosine. And you understand the derivative of sine is cosine. Well, think about it. If you're taking the first and second derivative, no matter what's on this side, if it's a cosine, isn't it going to produce sines over here too? So does it make sense to you that the answer is gobbledygook multiplied by cosine plus gobbledygook multiplied by sine? Like your answer actually has to have sines and cosines. Your first guess at this might have been y equals, well, didn't we say t squared plus bt plus c? Like that's what would happen because of the t squared, right? And then since that's a cosine of 2t, the only way you're going to get cosine of 2t is if your guess has a cosine of 2t in it. Like that would be a pretty good educated guess here, but it doesn't work. The reason it doesn't work is because you're going to take the derivative of cosine and it's going to be sine, and then you're going to have a sine in there. And you need the sine to go away. And the only way it's going to go away is if you got something in there to make it go away. So this is saying you don't get to stop there. Do you see that? Now, again, right now I'm ignoring this. I'm ignoring it. I'm just saying, hey, it was t to the second. So we got all the t's starting from t to the second on down. And then we got a cosine. But this is saying you also need a sine with exactly the same ingredients up here. Well, not exactly the same. Did you notice it didn't say this plus at squared plus bt plus c, except for now it's the sine of 2t?
That's what I wrote in my notes, and then I was trying to do a problem like 10 times, and I got it wrong at so many times.
Do you notice that it is saying for your second round of polynomials, you got to switch to new letters? So that sounds not good, because now I'm going to have 6 letters instead of 3, but it's sort of saying you're going to need them, I guess. And again, if we had time, I find myself wanting to try it just like I wrote it and sort of see, like, go, oh, that's interesting. Yeah, it doesn't work. That won't work. But in the interest of time, A, B, C, D, E, F.
So David, did you figure that out on your own? Like you just noticed it after the 10th time?
My gosh, yeah. I was looking at the next chapter and I saw that they did like they did this, and I went back and I looked at it and I just realized that I'd just written it down wrong. And
I
I
would have
was
never noticed that. I'd have never noticed
oh
that.
my gosh, just pages and pages and pages of math. Ugh.
Now, let's check this exception. Is this one of those problems that has an exception to it? In other words, do we need to consider throwing an extra t out in front of that? So it doesn't start out as at squared, it starts out as at cubed or something like that. Notice we're hoping this is the case, which is s is 0, t to the 0. T to the 0 is just 1, which means you get to ignore it, right? So we need alpha plus theta I to not be a root of the auxiliary equation. Well, again, I find myself a little confused by that language, don't you? So it's like, well, I don't know. I know what an auxiliary equation is, so at least I'll figure that out. Auxiliary equation for this is r squared minus 5r plus 6 equals 0. That happens to factor to r minus 3, r minus 2. So that's e to the 3t and e to the 2t, right? So in the last problem, we'd be looking for, is there an e to the 2t or an e to the 3t on that side? Well, notice there's e to the 0t on that side. So that's kind of good news, right? So it's like, oh, good, they're not matched. Thank God. But then what was all that, alpha plus theta business? Like, when did alpha plus theta show up?
When it's when there aren't real roots to the auxiliary equation.
Yeah, like that showed up with the non-real stuff, didn't it? Well, look over here. In other words, there's the alpha right there. And there's the theta right there. Like they're both over there. So for us, alpha is equal to 0 and theta is equal to 2. Notice this is saying they both have to match. They would both have to be exactly the same. What did we get? We got r equals 3. Isn't that 3 plus 0i? 3 is a complex number. That's 3 plus no I. We also got 2. That's 2 plus no I. Oh, good, good. Theta is 0 here. Theta is 2 here. Sweet. They both would have had to have been an exact match for that to happen.
How did you get theta was 2? Oh, because it was 2t. Never mind. Right.
Yeah, because it was 2t in our problem. So for us, theta was 2. But when we solved the auxiliary equation, we got 0 for I because it wasn't imaginary, right? We didn't get an imaginary answer. So it'd have to be cosine of 0t. And we didn't get that. So it's like, oh, good. That means my guess is right. I don't have to modify it. Notice if it was an exact match, I would be modifying it by just multiplying by t. So that means this is actually the correct guess. So up here, alpha is 0, theta is 2. Good. Because we got alphas of 2 and 3. So this is not a special case. This is not I before E, except after C. This is just good old I before E, man. Just write I before E every time, we'll be fine. So that means our guess is actually correct. And so let's go do it. Let's go take the first and second derivative, plug it all back in, force it to be equal to t squared cosine of 2t. And then life's going to be good. It just feels kind of daunting, right? Because notice that's a pretty big expression. This is actually the correct guess. So there's y. Let's go find y prime. Whew, this was really daunting. So I've got, of course, the product rule, the derivative of at squared plus bt plus c. Isn't that 2at plus b times the cosine of 2t left alone? And then plus at squared plus bt plus c left alone multiplied by the derivative of cosine of 2t. Derivative of cosine of junk is negative sine of junk. So that means this changes to a minus sign times the derivative of the junk. So that means there's a 2 out there. Do you agree that I successfully product ruled that expression? Looks like railroad, not product rule. Now I've got a product rule, the next expression. So it's the same thing. It's almost the same thing. So it's derivative of dt squared, which is 2dt, plus the derivative of et, which is e, times the sine of 2t left alone, plus the dt squared plus et plus f left alone, times the derivative of sine of junk, which is cosine of junk, times the derivative of the junk. There's my first derivative. Wow, this is horrible. Just horrible. So again, I'm thinking the same thing I thought a minute ago, which is, I wonder if I should be, collecting like terms, because, don't I have cosine of 2t's here and cosine of 2t's there? And so, should I collect this junk together a little bit and try to, make it a little smaller before I take the next derivative? I mean, I don't know. I just feel like I'm probably going to do something stupid, so I'm not going to. So there's my first derivative. Whew, this is horrible. What's my second derivative? Okay. Product rule, derivative of 2at plus b, that's just 2a, times cosine of 2t left alone, plus the 2at plus b left alone, times the derivative of cosine of junk, which is sine of junk, except it's negative, and then times the derivative of 2t is 2. So there's that one. Wow, do I have 4 product rules to take here? I think I do. This is not good. So then I'm looking at this one. What's the derivative of negative 2at squared plus bt plus c? That'd be negative 4at. Derivative of bt is b, but it's multiplied by negative 2. So there's that times the sine of 2t left alone, plus the mess, the way it was, plus the negative 2at squared plus bt plus c left alone, times the derivative of sine of junk, which is cosine of junk. Derivative of sine is cosine, no sign change, times 2. So that means that 2 out front turns into a 4. Wow, I feel like I'm on thin ice here.
I'm sorry, Doug. You're going to have to check this on your own because I have lost track.
Again, all I really want you to see here is this is not hard. The process is not hard, but to survive it without making a stupid mistake is pretty, like this question for me feels like I can't put this on the test. Do you agree with that? It feels like 2 out of 13 of you are actually going to not get it wrong, or you're going to spend literally 2 hours checking it to get it right. And again, you just need to understand, I'm aware of that. Like, but it's cool that you can get this. I mean, isn't that kind of cool? Isn't it kind of neat?
We were just talking in the chat. I was like, I'm so screwed for the next test. Like, I'm gonna make a mistake.
And obviously, even if no matter what I do, there's going to be some more challenging type of questions on this, but I'm going to be very merciful for stupid mistakes, but I'm going to need to be able to read your work, right? I'm getting lost. Let's see. Next product rule. The derivative of 2dt plus e is just 2d times the sine of 2t left alone. And then plus the 2dt plus e times the derivative of sine of junk, which is cosine of junk, times the derivative of the junk. The final one is this. The derivative, notice there's a 2 out in front. The derivative of 2td squared would be 4dt. And then 2et would be 2e times cosine of 2t left alone. Plus the 2dt squared left alone times the derivative of cosine of junk, which is the sine of junk. Derivative of cosine is actually negative sine, and then I got to multiply that 2 by 2, which means it turns into a 4. Whoa. It's like half a page just to write that idiotic thing down.
Do we have too many unknowns, or is it going to be okay because we have all the t squared and the t terms?
Yeah, I mean, I feel like this can't be working, don't you? Like, or if this is a problem, it just feels like people shouldn't do this. Like, I don't care if it can be done, you shouldn't do it.
The computer should.
It's not natural.
Yeah, this is not natural. This isn't human. Can you carve your skin with a potato peeler? Yeah, you can. Should you? Oh my gosh. Now I find myself thinking, okay, fine. And by the way, like, what could I do to make this problem easier? Like, if I did want to put something on a test, like, what could I have done to make this a little easier?
Maybe not the second derivative.
Yeah, maybe it doesn't have a second derivative. Maybe it only has a first derivative. Or maybe it doesn't have a t squared cosine of 2t. Maybe it's just a t cosine of 2t. Or maybe it's not even cosine of 2t, it's just cosine of t, because that 2t caused us a lot of problems, right? So it's like, you could do things to make this a little nicer. But, I find myself thinking the same thing, like, God, this is a terrible example. Like, there's no way I'm getting this right. All right, let's try.
Yeah, let's keep going. I'd like to see it carry.
No, we have to finish, right?
You need to formulate an email to RCC and ask for a raise. You can use me as a reference. If you're gonna go through with this, you need a raise, man. This is rough.
I'm gonna get it wrong, so they're gonna cut my pay for this.
Which makes it all the more admirable that you're still gonna do it.
Okay, so what I'm staring at is, because I'm going to try to not rewrite this whole thing. I'm going to try to do what I did a minute ago. I have minus 5 y primes and plus 6 y's, and I'm trying to get this to be equal to, notice that's a 1 t squared cosine of 2t. Notice I don't want any t cosine of 2t's. I don't want any 5 cosine of 2t's. I don't want any sine of 2t's. There's going to be a lot of zeros on the other side. Do you understand that? Because there's this one term on this side. And so
we probably are going to have enough equations because we're also going to have like t squared sine and t sine and the normal sine that we have to get rid of too.
Yeah, let's think about what we actually have here. What are we actually going to have? Aren't I going to have some t squared cosine of 2t's? And I'm going to have some t cosine of 2t's. And I'm going to have some just constant cosine of 2t's, in other words, 1. Aren't I going to have, isn't that what I'm going to end up with? I'm going to have constant cosine of 2t's, t cosine of 2t's, t squared cosine of 2t's. But then aren't I also going to have the same thing with all the signs, like a t squared sine of 2t, and I'm going to have a t sine of 2t, and I'm going to have a constant or 1 sine of 2t.
It's unfortunate because the book does not go through going through the calculation in the book is very difficult to follow. And so I think that this is where I went wrong yesterday eventually, is I didn't have enough equations to solve. And so
it is kind of cool to see this, but you will notice the book is not, I'm not assigning a question like this, even in the book assignment. Like they give you sort of a watered down version of this a little bit, and you can see why. But it's just kind of cool to, if you can survive it once. So what I'm going to do is start from the start and look at all of these. I'm going to try to go one at a time and cross these out and just like not screw up. This is going to be a miracle if I can pull this off. So notice I have a 2a cosine of 2t. Where does that go? Doesn't it go right there? Because that's cosine of 2t. Done. And notice I'm not multiplying y double prime by anything. And then I've got a minus 4at. But notice that's sine of 2t. Minus 4at sine of 2t. Where does that go? It goes right here. Minus 4at sine of 2t. It goes right there. And then I've got a minus 2b just sine of 2t. So that takes care of that. Then I'm into the next one. I got a minus 4at sine of 2t. So minus 4a under sine of 2t. Another minus 4a. That's interesting. And then a minus 2b sine of 2t. That's interesting, an exact match. And by the way, you know, would it have saved me some time to maybe collect all of this together? Are there some like terms there? Yeah, I could have done that. Maybe I should have. And then there's a minus 4at squared, but that's a cosine of 2t. Minus 4a t squared cosine of 2t. And then I've got a minus 4bt cosine of 2t. I hate myself. Minus 4c cosine of 2t. We're making it. And then a plus 2d sine of 2t. And then a plus 4dt sine of 2t. 4dt sine of 2t. And then a plus 2, I just screwed up because that was a cosine, right? So now I'm 2d sine of 2t. Which one did I just put that under? Minus 4d.
4d. We got this.
Got this. I just put it right here, didn't I? Is that where I put it?
Yeah, and that it should go into t cosine 2t, right? Plus 4d.
Ooh, so dangerous. 4t, 4dt. It should have went here, right? 4d.
Yeah.
Survived that. Plus 2e cosine. Plus 2e cosine. Yeah, we're making it. And then 4dt cosine. So another 4d. And then a 2e cosine. Another 2e. And then a minus 4dt squared sine. Minus 4dt. That's my first one of those. Minus first t squared sine of 2t. And then a minus 4et. And finally a minus 4f.
You know, it's actually kind of easy once you think about it as like cascading. It'll always like cascade down. Like you're just in the sine or cosine world.
Did you say this was easy, Connor?
No, I would never. No.
Yeah, you're right. There is a pattern to it. In other words, you actually could potentially catch a mistake here. But again, I want to point out, like, this is what mathematicians do. Like, we are way out in the universe here. You know, is there any actual practical problem where, you know, this is ever equal to t squared cosine of 2t? Notice our answer to that question is, I don't know. But it'd be amazing if it was, but probably not, right? I mean, probably there's nothing that's this weird. But notice it's now minus 5 times y prime. And so fortunately it's getting less, but I've got to kind of, you know, really highlight everything in here is multiplied by minus 5. And so, oh man, Now I have to go. I don't feel like I can survive this moving up and down. I'm going to copy it down below. I'll erase it later, but I'm going to copy it down here for now. Notice how important. Can you read your own handwriting? Like, notice my little T right here is pretty sketchy. I could easily screw that up. So I've got minus 10AT cosine of 2t. Minus 10AT cosine of 2t. Minus 5b cosine of 2t, or cosine of t. That takes care of that and that. Then I move to this one, minus 2AT squared sine. Minus 2A t squared sine. Oops, there's a minus 5, right? Minus 5 times minus 2 is actually plus 10. Where did I just put that?
T squared sine of t, sine of 2t.
It's right here, isn't it?
Yeah.
Plus 10a. And then 10 times bt sine of 2t. Plus 10b.
Isn't it minus 5?
Crap. Is it? Minus 5 times, it's also minus 2.
Oh, yeah. Okay, you're right.
So it's 10c. Whew, so dangerous. This is dumb. Why are we even doing this? Feels like a waste of time.
I'm kind of invested now, though.
I know. It's like we're too far in to stop now. But. So let's see. I better rewrite the minus 5 right here. So minus 10dt sine 2t. And then minus 5e sine 2t. Minus 5e. Oh my God. On top of that, it's not even going to fit. Takes care of that. And then notice it's minus 5 times 2. So that makes this actually negative 10 here. So negative 10 dt squared cosine. Negative 10d. And then negative 10e. It is cascading. And then negative 10f. Chance of success, virtually 0. If I was you, I wouldn't even be listening anymore. Lastly, we just have y, except for remember y was multiplied by 6. So again, I find myself thinking, since we're in this far, I've got to have to copy this down. And we're multiplying everything times 6, and you huge 6 up there. So we got 6a cosine, 6a cosine, plus 6b, and plus 6c. Oh my God, this is ridiculous. We're almost there, actually. And then plus 6d, and plus 6e, and finally plus 6f. What do you think?
I think
feel
this
really
is the
solid.
real Olympics right here.
This
Yeah.
is solid. We got it.
This is easy, but I would like you to stare at what we have. How many equations do we have?
6.
6. How many unknowns do we have?
6.
6. Any linear algebra people from spring terms? Like, oh, 6 equations, 6 unknowns. Yeah, man, that happens sometimes. But again, which one do we actually have sitting on the other side? Which one do we have? We only have t squared cosine of 2t, right? Which is this one. That one, if you will, is 1. Every one of the rest of these is none. We have none of them. Does that make sense? So let's think about what we got. We got 2a minus 10d has to be 1. That's from this top equation right here, right? Can't solve that because it's got 2 unknowns in it, so that's a bummer. And then this one got to be 0, but I'm staring at all my letters. Let's see, I got a minus 10a, That takes care of that. There's no more A's. Then there's a minus 4B and a plus 6. Oh, I can't read my writing. Yeah, that's a B. Is that an E? Is that a B? It's a B. So that's 2B. And I have no C's. I have 2D's. 4D and 4D is 8D. And I have a 10E. And all of that has to be nothing, because there's no T cosine of 2T's. And I do the same thing down here. See, I got 2A. Got any B's? Yeah, I got a minus 5B. Ooh, this is brutal. And then I've got a minus 4C and a plus 6C, which is 2C. No D's, 2 E's, so a total of 4 of them, and 1 F, minus 10F. That also has to be 0. Now I'm looking at this equation. I have 10 A's, my plus 2 D's. Why am I excited for the first time? Why am I excited right now? Yeah.
Because you can solve for one of A or D using the first equation.
Yeah, notice our first and our fourth equation just have A's and D's. So I can actually solve for A and D now. That's kind of fun. Otherwise, I would have just went into the matrix, math 261 people, and set up 6 equations, 6 unknowns, and let it do it for me, which I probably will do anyway. Now I'm looking at this one, minus 4A, minus 4A, that's minus 8A. Any B's? Yep, 10B. A, B, C, no C's, 1D, negative 10D. E, negative 4E plus 6E is 2E. And that has to be 0. And then finally, what about this last one? I have no A's. I have minus 4 B's. This is ridiculous. I have 1C, 10C. A, B, C, D, 2 D's. That's it. A, B, C, D, E. I have minus 5 E's. And I have minus 4 F's and plus 6 F's, which is 2 F's. Anybody see any pattern to these equations? Like, notice 1 and 4 have a lot in common. Not only do they have a lot in common, but what do you notice about them? There's a 10A and a 10D. There's a 2A and a 2D. What do you notice about the second and the fifth equation?
I think you're frozen, Doug.
Shoot. I don't know why this would freeze. Can you guys hear me? Yeah, you guys are frozen. Ah, you're back. You guys are moving again. Can you hear me?
Yeah, we can get.
So interestingly, I'm not going to go into this, but notice there is some things in common. In other words, like we have a 10A and there's a 10B. We have a 2B and there's a 2E. We have an 8D and there's an 8A.
Oh no.
10E.
We lost
He's about to tell us the secrets and then he freezes.
Suspense is killing me.
So
The secrets aren't.
if I was to go into the matrix, would you agree this is the matrix? I'm going in order here because I feel like this is way too dangerous. So we have 2A. This is like A, B, C, D, E, F. And this is the
Oh, he's
number.
back. You're back, Doug.
Welcome back.
I'm back. Oh, I didn't know I was gone. Sorry. So my first equation, I have two A's, no B's, no C's, negative 10 D's, no E's, no F's, and that's supposed to be equal to 1. My second equation, I have negative 10 A's, I have 2 B's, no C's, 8 D's, negative 10 E's, no F's, and it's equal to 0. My third equation, I have 2 A's, negative 5 B's, 2 C's, no D's, 4 E's, negative 10 F's, and it's all equal to 0. My fourth equation, I have 10 A's, no B's, no C's, 2 D's, no E's, no F's, it's equal to 0. My fifth equation, negative 8A, 10B, no C's, negative 10D, 2 E's, no F's. The whole thing is equal to 0. My final equation, I have no A's, negative 4 B's, 10 C's, 2 D's, A, B, C, D, E, negative 5 E's, 2 F's, and the whole thing is equal to 0. What size matrix is that?
6 by 6.
6 by, not quite.
6 by 7.
6 by 7. We got 6 rows and 7 columns thanks to that last one. This is a 6 by 7 matrix. This is why you take linear algebra. So if I type that matrix into my calculator as a 6 by 7 matrix and I ask it to find the reduced row echelon form of that matrix, it's going to tell me what all my coefficients are. Now again, I can do A and D by hand myself, but the other one seemed so ugly to me that I just felt like, let's use technology. Again, I'm like 5% sure that I got this right. It just seems like, how could I not have made a math mistake? But we have to finish now, so unfortunately I can't show you this. I'm going into second matrix. I'm going over to edit. I'm saying I want a 6 by 7 matrix. And I'm starting to type all this in. 2, 0, 0, negative 10. Even typing this all in seems impossible correctly. Negative 10, 2, 0, 8, negative 10, 0, 0, third row, 2, negative 5, 2, 0, 4, negative 10, 0, fourth row, 10, 0, 0, 2, 0, 0, 0, fifth row, negative 8, 10, 0, negative 10. How did I not have a note to myself that this is not a good problem to even do? 0, negative 4, 10, 2, negative 5, 2, 0. By the way, your assignment tonight, you know what they ask you to do for a question like this? You can see why now. They ask you to write down this guess right here and you're done. What's the answer look like? You're done. You see why? 2 of your 4 questions tonight. That's all you'd be doing with this question. But I just think it's cool to, I don't know, burn a few minutes and try this out. So again, I'm really, go ahead.
That's not a general solution, right?
No, this is going to be a particular one. So
No,
again,
I mean, like when the A's and B's and stuff are in there, it's not general. Then
no,
it's-
it isn't. That's right. Because it
just
isn't actually true until you actually find out what everything is.
Right. Okay.
So again, I'm almost 0 confident that, you know, I typed all those numbers. I just typed 42 numbers into my calculator. What's the chances I didn't type one in wrong? You know, it feels like 0. And one of my buttons sticks on my calculator. So, but I'm going second matrix, math, reduced row echelon form of matrix A. And it tells me this, if I change it to fractions, it tells me that A, and you can probably also tell that I made this problem up, right? Like if this was a book problem, do you think they would have made it up in such a way it might have been a little bit easier? B equals negative 10 over 169. It's just cool to see that you can do it. C won't even give me the depth fraction for it. It's approximately that. D is negative 5 over 52.
Glad we didn't do it by hand.
Negative 73 over 676. A, B, C, D, E, F, and F won't give me a fraction for that either, approximately negative 0.0206. This is approximately. So there, I found it. Notice it. The cool thing, if you will, is I actually did need every one of those letters. It's not like a whole bunch of them were 0. Does that make sense? I needed every one of them. They were all something. Crazy enough. But again, I would bet $0 on the correctness of my answer.
I got the exact same numbers. I think it's 100%, Doug.
You got the exact same numbers?
Yeah, let's check our work. It's time.
Yeah, let's go take the derivative of that baby and take the second derivative and plug it all in and see if it actually worked. That didn't take enough time. We need to take more time.
It's about the journey, not the destination.
Exactly. That's right. Let's make this last forever. Oh my gosh. Anyway, that's kind of cool. It's cool to see that it can be done, but you can also appreciate, wow, let's not be adding any e's into it. Like that just had a t squared and a cosine. What if it had an e in there? Oh man, that would have been like to take the derivative would have been like a double product rule. But it's cool to see that it can be done if somebody wanted to do it, but you shouldn't want to, or something wrong with you. Okay, sorry, that went way long. So good thing tomorrow we're not learning anything new. Tomorrow we're going to kind of put together everything that we've done. We're actually going to look at the homogeneous case and this non-homogeneous case. So we don't have to learn anything new tomorrow. We just got to kind of use it a little bit, and we're gonna again have ourselves a little family reunion tomorrow. And in a sense, tomorrow is what the test question would look like, because we really, although this seems crazy, we've only given half the answer right now to these problems. There's actually another part of the answer that we've ignored. So, but I'll make that clear tomorrow. All right. What do you do to recover from something like that? I sort of feel sorry, like I just injured you. I injured your brain. You're damaged.
So can you go back to the original problem so I can check this? It's got to be done.
I like that. Connor is a glutton for punishment.
Well, we got to know. We got to know if we got it right.
How are you going to know? My gut reaction is I'm looking at all
I don't
the
know
chat
either,
now.
man. I'm just going to start plugging and chugging and see what happens.
Thomas is like, what's the deadline to drop?
You might need the original differential equation.
Connor, I should have been a business major. I like David pointed out in the chat though that problem 24 is this is problem 24 in the homework, except for it's a first order differential equation. They don't make it a second order because you notice how much problems that caused this. So you can still take a guess at the answer, but you only need one derivative to do it. So you can actually survive it a little bit easier than this, but it's still not wonderful. But
it's second order. It just has the second derivative and the zeroth derivative.
Oh, it doesn't have the first.
Yeah.
So
you take two derivatives
still. But not the middle one. That's right.
And it's also got like a root. You have to multiply it by the you have to have an extra coefficient in there, not coefficient, extra variable for the t or whatever. So it's pretty much close to the same problem.
Yeah, so be warned, question 24. It only took me a half page to answer it, and that was using the matrix as we did here at the end. So it only took a half page, whereas this, what I did just showed you, took way longer. But it is an exception. In other words, our guess here was AT squared plus BT plus C. Well, it's an exception to the rule, which means you're going to need another T. So it'd actually be AT cubed plus BT squared plus CT. So be warned, 24 is a little bit easier, but kind of like this. So that is why
there's only four
made you suffer through this. All right.